So here also maximum load going to come in this area. So if this area is stronger, the bacteria is going to survive. It's not going to fail. So it's basically a bending load. How about this part? Circular cross section. Circular means hollow circular. Compression. Only compression? Can there be another one? Sorry? Torsion. Why torsion? Now you can twist, right? Twist around. So this part going to subject to two kinds of loads. Okay, torsional loads and compressive loads. And how about this support arm of the leg? Again, don't use word shear. Torsion. Maybe it is going to twist a little bit because of the friction in here. Right? When you are trying to twist, it's also going to, bend a little bit. But mainly, it's going to be a bending load. So now you can see that it's a very simple product, but still you find it difficult to recognize what kind of loads come onto that, right? So you can imagine an aircraft, a car, how much or the difficulty level of identifying the external loads. It's really hard, but if you identify them correctly, you can do a good design. And again, did you notice that different parts of this product has different shapes? Now this part is circular cross section and hollow circular, and this part here is cross section is like rectangular, right? And then this part also somewhat rectangular, but is the height wise higher, width wise smaller. So all these shapes are decided by the designer. It's not random choices. Thinking using engineering application principles. Right? So some shapes are better in withstanding certain kinds of loads, even with the same material. By simply changing the shape, we can make the product much stronger, stiffer. Right? So selecting the right shape for a design is very important. So next slide shows you some of the shapes for shapes which perform better in certain loads. For example, tension. For tension, best shape is solid circular shapes. So that will use less amount of material and withstand highest load possible. So if you change this one to a square shape, in order to withstand the same amount of force, you need to use more material. Right? So solid circular shape provide the optimum amount of material to perform the job. Okay? So you can see that whenever you see a member in a product or this device is subjecting only to tensile force, you can see that the section is solid circular because designer has selected that way. It is the best shape. And for the beams, so bending loads, the best shape is I section.